Welcome and a very good day. So today we are going to cover chapter 4.5 on recycle, 4.7F on product separation, bypass and purge. Let us see if you are given a process such as this here. You have two streams that's incoming and mixed in the mixer. And the mixing stream is sent to the reactor that is operated at certain temperature and pressure and with a certain catalyst. And they are reacted to form a product which then sent to the gas liquid separation column. The gas phase are recycled back into the reactor and the product stream is sent to another unit for product purification. The gas phase which is recycled, you can see here is being split into two streams, which is a recycle stream and a purge stream. The purge stream, which is the waste from this system, is treated in a stack before emitted to the atmosphere. The materials that are recycled back into the stream are mixed with the fresh feed, and then the feed are sent back into the reactor to mix and react again to increase the yield of our product. Let us see if we have components with a compound A, and A is reacting with C to produce B. So in this product stream, you will have A and C still in the system, even though A is very low in concentration or the time for the reaction is long. The reason is because the equilibrium of the reaction has been reached. So there is a need for you to separate B from A and C for you to be able to increase the yield of the process. So when A is recycled back into the feed, we want to reduce the cost to buy the fresh feed. And here you can see that A can be recycled back into the mixing point and sent back to the reactor system. So what kind of material do we recycle in our process? Sometimes we recycle catalysts. Why do we recycle catalysts? It is because catalysts are very expensive and they are not used up in the reactions. So regenerations can be done for the catalyst and they can be resent into the reactor. Sometimes we also want to make sure that the system that we are operating at is safe. So we recycle inert compound, for example, helium, argon, and nitrogen into our system to dilute toxic or hazardous or flammable chemicals that we use as raw materials. At other times, we will recycle our process or our utility liquid to save for energy and cost, as well as to ensure that the process conditions of our plant is maintained. For all of our analysis that we describe here, we will always say that our feed, recycle, and product streams are constant during our process by taking into account or by assuming that the system is in steady states. Unsteady states only occur when we have our startup process or if we have a shutdown. Distillation column is an example of a unit operation that has recycle stream. And there is no chemical reaction involved in this unit operations. For a non-reactive unit operation like distillation columns, we have this rules of thumb as the guide. Always remember that our mass in is equals to mass out. There are no accumulations in the process. There are no generations in the process. So for a distillation column, the feed that is going into the column is always in a liquid phase, and it can be a mixture of various components. So the low boiling component will be evaporated to the top of the column and exiting via the vapor phase column and then condense to form liquid distillates. Some of these liquid distillates are recycled back into the system to make sure that this is in equilibrium. So the liquid that is flowing down will be collected as the heavy key component or the bottom products of the distillation column. Some of the examples of where recycled streams are used are in a food dryer. As I show here, you can see that the ambient air are sucked into the system and then heat up in the burner. In the burner here, the air will be dried and heated to a certain temperature prior to sending them into the drying compartment. So in the drying compartment here, there will be heat transfer processes and mass transfer that will occur in such that the dry air will remove the water from our wet product and the wet air will be coming out from the system. The wet air then is sent again into the burner and the dry air is resent back into the system. So the process will occur in a cycle, and this is where recycling stream is useful in our unit operation. Another system where a recycle stream is used very commonly is in our reactor system. As I described earlier, recycling catalyst is very important because catalyst is very expensive, and at the same time they are not consumed in the reaction. The only problem with catalyst is that they sometimes becoming deactivated because they were poisoned. So catalysts that had been used in the reactor for some times might become deactivated. So we want to make use of them again. What we do is that we are removing the catalyst from the reactor, send them into the catalyst regenerator, and then we are sending them back into the reactor once they are regenerated. So usually when we want to regenerate the catalyst, we use steam or dry air to remove the coke or carbon generations on the surface. And to cover or to take care of a reaction system as well in our process, then our mass balance can be expanded to what we know, where mass accumulation is equals to mass in plus mass generation minus mass out minus mass that is consumed.